nuclear, magnetic, louder? Resonance spectroscopy.
Yep.
So, absolutely, this is the same technique that MRI is based on. So, nuclear magnetic resonance spectroscopy, one of the most important tools for an O chemist. NMR. Now, in NMR, once again, just like IR, we've talked about this yesterday. We're not getting into the physics of it. We know how is this working, what is it. We're not going to talk about the instrument, how is the instrument functioning. We will talk mostly about application. How do we use NMRs to figure out structures of compounds? Okay? Now, but one basic thing about NMR is that it is studying, or we can collect data for different nuclei. So we are looking at the nucleus, and there are some nuclei that are NMR active, meaning they will show up in NMR. Some don't show up in NMR. So the two that we will focus on, the two nuclei that we will learn about, one is the hydrogen 1, which is the hydrogen isotope of element hydrogen. Does anybody remember what the 1 stands for? Louder?
Atomic number?
No.
Mass.
Not that one. What does that 1 stand for? Somebody started to say it. It's the mass number.
Mass number.
Does anybody remember what is mass number? The A value? What is A value equal to?
P plus M protons.
Exactly. Z atomic number equals to protons. A value is protons plus neutrons.
Yep.
Where do they live? Where do these guys live?
Nucleus.
In the nucleus. So we are really only looking at the nucleus, although electrons play a role in this whole process, as we'll discuss. But please understand that we are focusing on this isotope, H1. Deuterium, H2, and tritium, H3, their nuclei do not show up in NMR. So H1 is specifically what we are looking at. And the other one that we will also look at is carbon-13. Because that isotope of carbon is NMR active, the other isotopes of carbon are not NMR active. So the two NMRs that we will discuss are proton NMR. This is proton NMR. Also, sometimes we write it as H-NMR because we are focusing on hydrogen. Or we can look at carbon-13 NMR, C-NMR. That's when we are focusing on the carbon atom. Are we all okay?
Yeah.
We will start with proton NMR. Once we are done with it, done some practice, then we will go to C-NMR. So let's start with proton NMR. Once again, we're not discussing physics of it. What does resonance mean? How is it done? How is the instrument set up and all of that stuff? We are not getting into. The idea here is that we place a sample in a magnetic field. So the instrument upstairs that we have, the instrument has a magnet, and then the sample goes inside that magnetic field. And then we apply energy in the form of radio frequency radiation. The radio frequency energy values, then we supply that, which causes the nuclei to also rotate on their own axes, creating their own magnetic field because they are charged. And at the point where the nucleus magnetic field becomes in resonance with the external magnetic field, that's when we see a signal. So the resonance part is basically talking about the magnetic fields of the nucleus and the external coming in resonance with each other. So that's the basic, again, don't have to worry about the physics part of it. Now, how do we apply proton NMR? That's the one we are focusing on first. H-NMR, meaning we are looking at H atoms in the molecule only. So how do we use proton NMR spectroscopy to figure out structures of different compounds? Are you guys with me?
Mm-hmm.
Yes? Okay. You know how when you're watching, you get watching a TV show or something, you're really into it, and it's a weekly thing, and they stop it right at the cliffhanger, and now you have to wait for a week to figure out what happened next. Here's my cliffhanger. Let's wait. Before we talk about that, I want to introduce us to something that is going to be very useful in this whole process. It's called Index of Hydrogen Deficiency, IHD in abbreviation. Some books call it degree of unsaturation. So in this whole process of using NMR to figure out structures of compounds, I personally find this to be very useful. So let's go over this first, learn this, and then we'll start proton. What this is basically telling us, number of hydrogens short of a fully saturated molecule. And that is extremely useful information to have. Now, one IHD, so if the index of hydrogen deficiency is 1, what that means is that the molecule, whichever compound you're looking at, has 2 hydrogens less than a fully saturated compound. By the way, which family is fully saturated? Louder, please. We're not talking about atoms, molecule. Alkanes. Exactly. Alkanes have the maximum possible number of hydrogens for the given number of carbon atoms. So if IHD is 1 for some molecule, which basically tells us that it has 2 hydrogens less than a fully saturated molecule, in other words, an alkane. Alkane is as saturated as it gets. What does that practically mean? 1 IHD corresponds to 1 pi bond, because in order to make 1 pi bond, you have to give up 2 hydrogen atoms.
Yep.
Or means 1 ring, because to make a ring, you have to also sacrifice 2 hydrogen atoms. So 1 IHD equals 2 hydrogen atoms, and that means 1 pi bond or 1 ring. Are you guys with me so far?
Yeah.
Okay, so how do we figure it out? What is the process of figuring out IHD in a molecule? So let's look at different kinds of compounds. Let's start first with hydrocarbons. What are hydrocarbons again?
Molecules that are just made of C and H.
No heteroatoms, right? C and H only. So how do we figure out IHD for a hydrocarbon? Step number 1. Figure out, determine the alkane formula with the same number of carbons. And we'll do examples. Okay? Your saturated formula with the same number of carbons as the molecule you're trying to calculate IHD for. You guys with me?
Yep.
And then IHD equals half of the difference between saturated formula and given formula. That's the process, those 2 steps for a hydrocarbon. For example, let's see how that works. Let's say we need to calculate the IHD for C7H8. I'm just making something up. So how do we do that? What's step number 1? So what is the saturated formula with 7 carbon atoms? What would that be?
C7H16.
And how? 2n plus 2.
Yep.
Right? Exactly. Everybody agrees?
Yep.
That's the max number of H's possible for 7 carbon atoms. Second, what is the IHD for this then? Half of C7H16 minus C7H8. What is that equal to, anybody? Louder?
Or H4.
4 is the IHD. What does that mean? It means that there are maybe 4 pi bonds, maybe 3 pi bonds, 1 ring, maybe 4 rings, maybe 2 pi bonds, 2 rings, any combination of pi bonds and rings so that they all add up to 4. And that's really useful information. Does that make sense, everybody? Are we all good? Yes? Can you go ahead and tell me what is the IHD? And I'm just making something up here. Again, C11H. What's the IHD for that? What did I do?
Well, I'm just debating the answer.
Oh, but it's the same. Okay, can I change it? It's 4,
Yeah,
which is the
but-
same. Why do the same? Okay. Okay, how about what's the IHD for that compound? I'm looking for the eraser. Yes, what's the IHD for that, please?
5.
Right? 5? How? Again, half of, what's the saturated formula with 11 carbons? C11,
H24.
24 minus C11, H14. So 20, carbon cancels out because it's the same. So 24 minus 14 is what?
10.
And half of that is what?
How did you get 24?
What's the alkane general formula?
CnH2n plus 2.
Okay, thank you.
Yeah. We good, everybody? Does that make sense? Okay, then let's look at what about molecules that have heteroatoms? What if it has oxygen or nitrogen or sulfur or halogen? Then how do we calculate the IHDs? So similar steps with a little bit more to do. Okay. Compounds with halogens, fluorine, chlorine, bromine, iodine, any of those. What do? Step 1, we figure out a modified formula. What is that? That is basically the given formula plus 1 hydrogen for every halogen and drop the halogen. So first we take the given formula and we modify it. How do we modify it? We basically replace every halogen with a hydrogen. Right? Everybody okay?
Yep.
And then IHD equals half of saturated formula, but this time minus the modified formula. Okay? So for example, if you needed to calculate the IHD for notice there's a halogen there, right? So first we modify the formula. So what is the modified formula going to be for this guy?
C6H8
So replace the halogen with a
hydrogen.
hydrogen. So it becomes C6H8. Everybody okay? And then formula. So IHD is equal to half of, so can someone tell me what is the saturated formula with 6 carbon atoms?
C6H14.
Minus the modified formula. C6 cancels out. So what is that equal to? 14 minus 8
Is
is,
6.
and 6 divided by 2, 3 IHD. What does that mean? Maybe 3 pi bonds, maybe 3 rings, maybe 2 pi bonds and a ring, maybe 2 rings and a pi bond, maybe a triple bond. I mean, so all of those combinations possible. Please remember, 1 IHD is 1 pi bond or 1 IHD is 1 ring. So any of those combinations possible. Hey,
I just want to look for something.
yeah?
I keep needing
Does-
to grab things off the desk, sorry.
Does that make sense, everyone? Questions? We'll do more examples, but make sure you understand the process.
Thank you.
You're welcome. Okay, what about compounds with oxygen or sulfur in group 6A?
Sorry, I just
No,
wanted to
please.
know this. What does drop X mean?
Drop, meaning you removed it.
X is a halogen.
Oh, X is halogen. Oh, sorry. X is a symbol used for halogens.
No, I got that. I just,
Yeah.
I didn't know what you meant.
That's what I mean. So drop the halogen.
Okay.
Oh, that would be very confusing if you don't connect the two, yeah. So we basically dropped the Cl, but just added a hydrogen. Okay, what about if there is oxygen or sulfur in group 6A? So step number 1, modified formula. In this case, the modified formula is figured out by taking the given formula and drop the O or the S. Don't really have to do anything else. You don't have to add hydrogens, you don't have to do anything, you just drop that.
Drop O's and S's?
Or S, whichever it
Yeah,
is.
drop O or
Or
Yeah.
if there's both? If there's both?
Drop
just
both of them.
Okay, drop
Yep,
both. Right, got
exactly,
it.
exactly. Whichever one or ones are there, drop them. The rest is the same. IHD equals half of saturated formula minus the modified formula. So for example, so what would be the modified formula?
C4H6.
Does everybody agree? All we're doing is dropping or just taking the O's and S's out. Nothing else needs to be done. And then what is the IHD going to be? Half of, what's the saturated, no, you're good, you're right. Half, what is the saturated with 4 C's?
C4H10.
And then minus the modified. So 10 minus 6 is divided by 2. That's it. You're done. You good? I wonder if you're noticing there's a pattern here. Group 7, we added a hydrogen and dropped the halogen, right? Group 6, we dropped but we didn't add a hydrogen. Any guesses? What would we do for group 5A? Louder?
Add one,
Add what?
add a hydrogen.
We added. We didn't add. So go in the number line. What comes after 0?
1.
Take away. After 0. Okay, fine. Okay. Which direction I mean? Before 0. Okay. Forget it. Don't worry about it. I was trying to do something, didn't work. It's okay. So modified formula in this case is given formula minus 1 hydrogen for every nitrogen or phosphorus and drop. Okay, so this time you're taking a hydrogen away. And rest is the same. Calculate the IHD using the same formula. We okay? Okay, so for example, I need you to calculate the IHD for C7H9N, let's say. So, first modified formula. What would be the modified formula from this?
C7H8.
Do you all agree? Right? You're subtracting a hydrogen. And then rest is the same. So what is the IHD equal to? Half of, what's the saturated with
C7H16.
minus C7H8. What is 16 minus 8?
8.
Divided by 2.
4.
Who's your IHD? Does that make sense, everybody? Yes? Yes, please.
Sorry.
No, please.
I've been lost with the IHDs. So the C4, so for that one?
Yes.
C4H10.
This one?
Yeah.
8,6.
Oh, and then there's a.
Oh, that's the saturated formula. Saturated formula is the alkane, CnH2n plus 2. So if there's 4 carbons, that should be 10. Does that make sense? Yeah?
Thank you.
Yeah? Anything else, guys? What if they're all together in one compound? Do the same. Do everything that applies based upon what is there. So let me write something. Give me a second. Question is, calculate the IHD or the degree of unsaturation, whatever you want to call it, for the following. Give me a minute. Okay, please go ahead. Calculate the IHDs for these 2 examples.